Assalamu alaikum everyone. Welcome to our first lecture for the course Introduction to Artificial Intelligence. In this introductory lecture, we shall look at the following topics. First, we try to answer the question that is probably more important to you at this point, which is, what is artificial intelligence? It turned out that there is no straightforward answer to this very simple question. Over the relatively short history of the subject, different pioneers in the field have offered different definitions for the subject. There are at least 4 different perspectives of looking at artificial intelligence. These are acting humanly, otherwise known as the Turing Test approach, thinking humanly, also called the cognitive modeling approach, thinking rationally, or the laws of thought approach, and finally the acting rationally approach, also called the rational agent approach. We shall look at each of these different perspectives one after the other. After that, we shall then look at the foundations of artificial intelligence. In other words, what are the different academic disciplines that contributed to making AI what it is today? Then we look at the history of artificial intelligence. And then finally, we look at the state of the art. In other words, what is the stage of AI right now? What can we do with it? What kind of problems can AI help us to solve at this very time? So these are the topics that we are going to study in this introductory lecture. Let us start with the first one. What is artificial intelligence? As we said, different pioneers have had different thoughts about the meaning of the term artificial intelligence. Let us go through some of these different categories. There are 4 of them, as we shall see. We're going to go through them clockwise, starting from the bottom one. Let's read through the 2 definitions in this first group. The first one says, artificial intelligence is the art of creating machines that perform functions that require intelligence when performed by a human. This is the definition given by Kurzweil in 1990. Another similar definition goes as follows. It says it is the study of how to make computers do things at which, at the moment, people are better. So if you look at both of these definitions, they are talking about developing systems that behaves or functions like human, like people. Okay, this is one category. Let's look at the next category. Again, there are 2 definitions here. The first one says, AI is the exciting new effort to make computers think, machines with minds in the full and literal sense. This is by Hoagland in 1985. And the second one says, It is the automation of activities that we associate with human thinking, such as decision making, problem solving, and learning. This definition was offered by Bellman in 1978. So again, if you look at these two critically, the key word here is thinking like human. Thinking like human. All right, let's move to the third category. So the first one here says the study of mental faculties through the use of computational methods. Okay, this is by Charniak and McDermott in 1985. And the second one says the study of computations that make it possible to perceive, reason, and act. Now, in both of these definitions, there is no mention of human. Rather, they are concerned about computational models or computational processes. But they want to use those computational processes to model mental faculties or to perceive and reason. Okay, in other words, thinking is still here, only that it is not thinking in the sense of human. We call it thinking rationally. The last category is as follows. They define AI as a field of study that seeks to explain and emulate intelligent behavior in terms of computational processes. And the second one says, the branch of computer science that is concerned with the automation of intelligent behavior. So again, in both of these two definitions, the idea is to have systems that behave intelligently using computational processes. Now, the four different categories or different perspectives of looking at AI can be summarized in this table. The definitions on the top, they are concerned about thought processes or thinking and reasoning, whereas the one at the bottom are concerned about behavior. So this is one way to look at the four different definitions. They can be grouped into those that are concerned about thinking and those that are concerned about acting. Another way of looking at them is those on the left and those on the right. It says the definition on the left measure the success of an AI system in terms of its closeness to a human performance. Is it going to do as good as human? Whereas those on the right, they measure the success against an ideal performance measure, which is called rationality. Okay, thinking rationally and acting rationally. When do we say a system is rational? A system is rational if it does the right thing, given the knowledge it has or given what it knows. Now, historically, all these four approaches of AI have been followed by different groups of people. A human-centered approach obviously must involve the observations and hypotheses about humans, whereas the rational approach involves a combination of mathematics and engineering. Let us take each of these four different approaches in a little bit more detail, starting with the bottom one here, acting humanly. Okay, first the acting humanly approach. This approach is best explained using the Turing test. The Turing test, proposed by Alan Turing in 1950, was designed to provide a satisfactory operational definition of intelligence. So let's try to explain what the test is about. As you can see in this figure, the Turing test assumes we have two rooms which are separated by a wall. In one room, we have a human and an AI system. And in the other room, we have a human interrogator who will be sending written questions to the other room and receiving written responses. Now, Turing proposed that if after sending his questions and receiving written responses, the interrogator here cannot determine who actually answered the question. Is it the human or is it the AI system? If he cannot determine, then the AI system here is considered to be really an artificial intelligence system. In other words, what Turing is trying to say is an AI system is one that behaves exactly like a human. Now, obviously, as a side effect, if an AI system can satisfy this Turing test, then it means it has a lot of capabilities. We list some of these capabilities. One is that it must understand natural language processing. Because remember, the human interrogator will be sending his questions in writing. So how else will the system be able to understand the meaning of the question if it doesn't understand natural language like English or Arabic, for example? So essentially, Turing is saying an AI system should be one that can understand and process natural languages. Two, obviously the system must have some way of representing knowledge, because it cannot answer a question if it doesn't have the information that is required to answer that question. And therefore, AI system must be able to represent knowledge in some way. Next, the system must be able to do reasoning based on the question it is given, to look at its knowledge base and decide what is going to be the right response. Any system that can do this obviously has a means of automated reasoning. And the last part is that the system must be able to learn. The knowledge here within the system must not be fixed, because the interrogator can ask any question basically. And the idea is the system should be able to adapt and learn this new knowledge. Now, a modified version of the Turing test, which is called the total Turing test, added two other scenarios to the test. I remember the original one, the interrogator should send his questions in writing. Well, if he is sending the question in writing, we cannot know or we cannot test whether this AI system can visualize or can perceive, okay, whether it has perceptual abilities. So in the total Turing test, they added another element, that not only the interrogator can send his questions in writing, but actually he can also send them as video signals. So the AI system if it is to pass the Turing test, should be able to look at the video and interpret it. Okay, this is one. The second aspect that is added to the total Turing test is the ability to handle objects, physical objects. So for example, the interrogator may send a pen in the other room and ask, what is this? So unless the AI system has the capability to actually physically touch these external objects, it may not be able to handle that kind of question. Okay, so to pass the total Turing test, therefore additional capabilities are needed for by our AI system. It should have a computer vision to be able to perceive objects, and also it should have some robotic arms to be able to manipulate objects, okay, and move about. Now, these 6 disciplines, the 4 that we mentioned in the last slide, and this additional 2, compose of most of what AI is today. And therefore, Alan Turing deserves a lot of credit for designing a test that remains relevant 70 years later. All right, so this is the acting humanly approach. Let us now look at the second approach, the thinking humanly approach. So here the approach is that the AI system should be able to think like a human. Obviously, if we are going to say that a given program thinks like a human, then we must have some way of determining how humans think, so that we can be able to measure whether our AI system is thinking the same way. Okay? And to be able to do that, we need to get inside the actual workings of a human mind. There are a few ways one can try to do this. One way is through introspection. What this means is, after a human did a certain action, we go now and study why did he did that action. Okay, what made him to do that? All right. Another way is through psychological experiments, observing a person in action, or by studying the brain, the imaging of the brain. So obviously, these different ways of determining how a human mind thinks are a little difficult for a computer science person to actually measure. And unless you can be able to measure that, then you will not be able to tell whether your program is thinking the same way. All right, so that's what we are saying here, that once we have sufficiently precise theory about the human mind, then it becomes possible to express the same theory to a computer program. If the program's input-output behavior matches the corresponding human behavior, then that will be an evidence that some of the program's mechanisms could also be operating in humans. In other words, the computer system will be thinking in the same way as a human. As an example of pioneers who try to follow this approach, we have Alan Newell and Herbert Simon. These are the two guys who developed a system called GPS, general problem solver in 1961. These people were not content merely to have their program solved using their GPS system, but actually they were more concerned with comparing the trace of its reasoning, what steps it followed to arrive at a solution, and try to compare that with the way the human thinks. Now, the interdisciplinary field of cognitive science brings together computer models from AI and experimental techniques from psychology to construct a precise and testable theories of the human mind. However, real cognitive science is necessarily based on experimental investigation of humans. And as computer scientists, we don't have humans to investigate with. What we have are computers. And therefore, in this course, we shall not be exploring AI using this approach. Okay? The third way of looking at AI is called the thinking rationally approach, also called the laws of thought approach. This approach is what the people that are expert in logic, also called the logicians, this is how they view AI. So logicians in the 19th century, they developed a precise notation for statements about all kinds of objects and their relationships. In other words, they represent different objects and their relationships in terms of logical expressions. And by 1965, they were able to develop programs that in principle can solve any solvable problem that is described using this logical notation. Although if no solution exists, the program might loop forever. But if it can be solved, then the program will eventually be able to solve it. So the so-called logicist tradition within AI hopes to build on such programs that were developed earlier to create intelligent systems. There are two main obstacles to this approach. One is that, first, it is not easy to take informal knowledge, which normally is what we have in real life, and convert it into formal terms using logical notations, especially if that knowledge is not 100% certain. And most real life knowledge is not 100% certain. So it's very difficult to be able to convert it to the form that these logicians will want it to be. And obviously, if they cannot represent it in terms of logical expression, then they cannot solve it. This is problem number one. Problem number two is that there's a big difference between solving a problem in principle and solving it in practice. Even problems with just a few hundred facts can exhaust the computational resources of any computer, unless if it has some guidance as to which reasoning steps to take first. Okay? So this is the problem with this approach. It's very difficult to convert real-life problems to formal logic. And two, Even if you are able to convert, you may not actually be able to solve the problem because it takes an incredible amount of resources. And in fact, this is what happened at the end, especially with the discovery of uh, problems that are exponential in terms of their tractability. It turns out this approach cannot solve those problems. The final approach we will look at is the acting rationally approach, also called the rational agent approach. This approach is based on designing agents that will act to solve the AI problem. So maybe we can start by defining what is an agent. An agent is something that acts. Well, you may say all programs do some action. So what really is an agent? Well, all programs do some action, but computer agents are expected to do much more, actually. For example, they are expected to operate autonomously without human intervention. They are expected to be able to perceive their environment, and they are expected to perceive over a prolonged time period. They are also expected to adapt to changes in the environment. And finally, they are expected to create and pursue goals. All right? So this is the idea of this fourth way of looking at AI system, is to be able to develop agents that exhibit these properties, which can then be used to solve the AI problems. So it says here that the laws of thought approach, which is similar to this approach because it also involves rational, but instead of rational behavior, it was thinking about it in terms of rational thinking. So in the laws of thought approach to AI, the emphasis was on making correct inference, making correct conclusion. Now, making correct conclusion is obviously part of being rational, but it is not all of rationality. Okay? It says here that, however, making correct inference or drawing correct conclusion is not all of rationality. In some cases, there is no correct thing to do at a particular point, but something must be done anyway. So if you are following the laws of thought approach, you're going to get stuck. This is why we saw that some of their programs can run indefinitely, because they have to make a correct conclusion before they decide what to do. But there are cases where there is no correct conclusion. So what do you do? So in this particular case, or the acting rationally approach, you just try and do something anyway. Okay? Say, but something must still be done. This is one. In another case, acting rationally is not even the preferred option. For example, consider recoiling from a hot stove with a reflex action. In other words, suppose accidentally you touch a hot oven. Do you wait to decide what is the rational thing to do before you act? Or do you just quickly remove your hand from the hot oven? Obviously, you do it by reflex action. You immediately, without even thinking, remove your hand. Whereas if you are to follow the laws of thought approach, you have to now look at all the possible options before you decide, okay, the best thing is to now remove my hand. It doesn't work this way in this case. All right? So those are the two issues with the third approach if you compare it with this approach number 4. Now, the skills needed for passing the Turing test will also allow an agent to act rationally. Okay, it should be able to represent knowledge. So our agent should be able to represent knowledge and be able to do automatic reasoning, and they should be able to understand and process natural language. Okay, so the rational agent approach has two advantages over the others. One is that it is more general than the laws of thought approach, because as we said, correct inference or making correct conclusion is just one of many possible mechanisms for achieving rationality. And two, it is more amenable to scientific development than approaches that are based on human behavior or human thought. Because here the standard is defined by mathematics, engineering, and so on. Whereas in the other approaches, the concentration is on studying the human mind and human behavior and trying to mimic the way it works. So this rational approach actually is more applicable or is more receptive, if you like, to scientific development. And therefore, in this course, we shall concentrate on the general principles of rational agents and the components that can be used to construct them. So if we may conclude this section, we can say that a rational agent is one that acts so as to achieve the best outcome, or when there is an uncertainty, to achieve the best expected outcome. We shall study rational agents in detail in our next lecture. Okay, the next topic is about the foundation of AI. Here we are going to consider the fields or subjects that can be considered as the foundation of AI. Just a quick run through those different disciplines. It says here that AI is a multidisciplinary field whose development to its current state is as a result of contributions from many other fields. Some of this includes philosophy. So from philosophy, AI borrowed things like logic, methods of reasoning, mind as a physical system, foundations of learning are also from philosophy, language, and the idea of rationality. All of these are borrowed from the old field of philosophy. Of course, AI borrowed from mathematics, formal representation, proofs, algorithms, computation, decidability or undecidability, interactability or tractability, and probability. These are all concepts that are used in AI which directly come from mathematics. So mathematics can be considered as one of the foundations of AI. We also have economics. Okay, in economics, AI borrows things like utility. An AI agent is always trying to maximize its utility. We shall see this later. Okay, decision theory, rational economic agents, Again, these are all borrowed from the field of economics. Then, of course, we have neuroscience, where AI tried to borrow the concept of neurons uh, as they are in the human brain, try to artificially create neurons. Okay, so the concept of neurons as information processing units are borrowed from neuroscience. Okay, AI also borrowed from psychology and cognitive science, as we discussed in one of the different approaches for defining AI, the laws of thought approach. It's how people behave, how they perceive, how they process information, and how they represent knowledge all come from this cognitive science stroke philosophy. And then, of course, computer engineering, because AI definitely rely on fast computers to be able to solve these big problems. We need not only the logic, but also a suitable fast machine with enough memory to be able to solve the problem. And this is provided by the computer engineering field. The final field from which AI borrows is called control theory, from where AI borrows things like design systems that maximize an objective function. This is one of the main things that is studied in control system. They are always trying to maximize an objective function. So the same thing we do in AI, always the agent is trying to maximize its utility. We shall see that when we start looking at some of these techniques. Or there's one more, which is linguistics, of course. We mentioned that as one of the things required to pass the Turing test. The agent must be able to understand natural language. Therefore, knowledge representation, grammar, natural language processing are all borrowed from the linguistic fields. Okay, so these are basically the different fields that help AI to develop to what it is today.